So we'll talk about probability, and in fact, we're going to talk about probability when more than one event is occurring. So we're going to talk about compound probability. Probably what makes this the hardest or a very difficult task is the fact that every problem is not the same. And so I'm going to try to give you keywords so you know when to do what. So this first problem says, a bag contains 3 marbles that are red, 5 blue marbles, and 4 green marbles. If 3 marbles are drawn out of a bag, what's the exact probability that all 3 marbles drawn will be blue? So here's what I want to happen. I've got 3 things. I want to draw a marble out of the bag, and I want it to be blue. And I want to draw another marble out of the bag, and I want it to be blue. And I want another marble out of the bag, and I want it to be blue. So I have to think about what happens with this first marble. The probability that I get blue on the first marble is 5 out of 12. But with probability, we always assume that whatever we're drawing for, we're going to get. So if I draw for a blue and I get a blue, now there's only 4 blues left in the bag out of 11 marbles for the second draw. And if I get one here, then there'll only be 3 marbles that are blue left in the bag out of 10 for the last draw. And the probability that this will happen, and this will happen, and this will happen, you multiply. So when I multiply these together, I get 20 times 3, which is 60. And on the bottom, I'll have to use my calculator. 12 times 11 times 10. I would probably actually reduce before I got that number. Is 1320. And then that reduces to 1 over 22. And so since this problem asks for the exact probability, I'm going to leave it just like that. Okay, let's look at the next one. Says you get 3 red, 7 blue, 5 green. If 2 marbles are drawn out of the bag, what's the probability? So this time I'm going to round that both. So I want to get, again, blue and blue. And when I have an and, I'm going to multiply. So the probability of blue is 7 marbles out of 15 marbles. But once I draw the next one, there will only be 6 marbles to choose from out of 14. And so I'm going to have 7 times 6, which is 42, over 15 times 14, which is 210. And when I divide that out, I get 0.2. And I know I want to divide this one time because I say to the nearest thousand. Okay, let's look at the next one. This one's very wordy. In an Algebra 2 class of 25 students, 5 of them play basketball, 10 of them play baseball. There are 12 students who play neither. So I've got 25 in the class, 5 play basketball, 10 play baseball, and 12 play neither. What's the probability that they play basketball and baseball? I think the easiest way to do these problems is to set up a table. And we did some of these in the previous notes. So I'm going to set up a table, and I'm going to talk about basketball and ones that don't play basketball. On the other column, I'm going to put baseball and no baseball. And then I'm going to make a table. All right, so this is going to be my total, and this will be total. So let's go fill in our columns. The first thing they tell us is we have 25 students. So I know that my total down here is going to be 25 students. 5 of them play basketball, so I'm going to go under the basketball column, and 5 play basketball, so I'm going to put a 5 right here. 10 play baseball. So here's the baseball column. 10 play here. There are 12 that don't play either. So they don't play basketball and they don't play baseball. So I'll have 12 in this spot. Now I'm ready to go in and fill in the missing values. So I know the total is 25, so this number must be 15. And I know that the total here is 15, so this number must be 12 because 3 plus 12 equals 15. I know that this must be a 20 because 5 plus 20 equals 25. This has to be a 2 because 2 plus 3 is 5. And this one would have to be 8 because 8 plus 12 is 20. Now I'm ready to go back and see what they're asking me to find. What's the probability that a student chosen randomly from the class plays both basketball and baseball? The ones that play both basketball and baseball would be in this column right here. So the answer would be 2 out of 25. We could also do that the other way, where I say if they play basketball, there were 2 out of 5, and played baseball. What was baseball? I'm sorry. If you played basketball, there were 5 students out of 25. If you played, let's say that again, 5 out of 25. The ones that played baseball were 10 out of 25. And when you reduce that, that goes to 1/5, and this goes to 2/5. So you get 2 out of 25 when you multiply those together. So you get the same answer either way. But I think the tables are a good way to do that. There's a spinner, and I'm going to start mixing these problems up now. There is a spinner with 5 equal areas, numbers 1 through 25. If the spinner is spun 1 time, what's the probability? So I'm finding probability that the result is a multiple of 5 and a multiple of 3. So I want to think about, it's got to be either one or the other. So I'm going to think about what this looks like. I've got the numbers 1 through 15. So first I'm going to think about the multiples of 5. I have this one, and this one. So the multiples of 5 are 3 out of 15. Or the multiples of 3. So let's think about the multiples of 3. I have 3, 6, 9, 12, and 15. So 1, 2, 3, 4, 5. So if I want to find the ones that are one or the other, I'm going to find the probability of this and add it. Notice I'm adding to the probability of the other. So I have 8/15. But what I've noticed here is that 15 was counted for the multiples of 5 and it was counted for the multiples of 3. So I have to take away that number because I've counted it in this set of numbers and this set of numbers. So if I want to find the probability that I pick a multiple of 3 or multiple of 5, there are 7 of them. 1, 2, 3, 4, 5, 6, 7. If I didn't subtract the 1, I would be counting this number twice because it is wanting one or the other. So notice with or, we're adding. Okay, let's go to the next one. John has 9 different flags that he wants to hang on the wall. How many different ways? We talked about that last time. What do we do when it's how many different ways? We multiply. How many different ways can he arrange the flags in a row? So I think about 9 different flags. If he chooses a flag for the first spot, he only has 8 flags to choose from for the next spot. 7, 6, 5, 4, 3, 2, and 1. This is a permutation. It's actually what we would call 9 factorial. You can try to find that button on your calculator, but probably most kids would choose to just do 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1, and they would get 362,880. If you think about setting up passwords, you can see why they ask for so many blanks and putting so many characters in. It increases the number of ways that password can be hacked. There are 16 students running in a race. How many different arrangements or how many ways, so I know I'm going to multiply, can I get first, second, and third place? Well, if there are 16 students running in a race, there are 16 students that could finish in first place. Once somebody finishes in first place, there are only 15 students to choose from for second place. And once somebody gets second place, there are only 14 students for this place. So when I multiply those together, I get 3,360 different ways that that could happen. So I've tried to pick ones that I think here that you might see in Delta Math. In a class of students, the following data table represents how many students play an instrument or a sport. What is the probability that a student plays an instrument given that they play a sport? So let's go ahead and look at our table and make a totals column. So totals now, 7 people play a sport and 21 don't play a sport. 28 total. 23 don't play an instrument and 5 play an instrument. What are we trying to find? The probability that a student plays an instrument given that they play a sport. So they play an instrument given that they play a sport. So let's look back at how many students play a sport. So the ones that play a sport are 7. And now I want to know the probability that a student plays an instrument given that they play a sport, and that would be 3 of them.